There's a very specific kind of paralysis that happens when you sit down to build something with AI.
Oh, yeah. I know exactly what you mean.
And it's not always the blank page problem. I mean, sure, staring at a blinking cursor is terrifying for anyone.
Right, the classic blank page.
Exactly. But I actually think the opposite problem is getting way worse right now.
You mean the drowning in data problem?
Yes, the too much context problem. You've got, a project plan in a PDF, a half-written spec in a Google Doc.
A Slack thread where the engineering lead changed their mind 3 times.
Right, 3 times, and maybe a handful of URLs. And you look at that messy pile and think, how on earth do I get a machine to understand all of this without hallucinating or just completely giving up?
It is the classic signal-to-noise ratio issue. We used to complain that AI didn't know enough, but now for anyone building in the enterprise space...
Whether you're a CTO or a founder.
Exactly. The problem now is that we are feeding the AI this incredibly messy soup of information and expecting it to serve us a Michelin star meal.
And usually we just get soup on the floor.
Yeah, soup everywhere. And that is exactly why today's deep dive is going to be so valuable for you. We are unpacking 2 really sophisticated technical reports from the Prompt Optimizer AP repository.
Specifically from the user Nivlu Yuan.
Right. And we're looking at how to move from that absolute chaos to actual usable clarity.
So we're covering 2 specific systems today, the context engineer subsystem and something called intent engineering.
And just to set the stage here, this is not about prompt tips. We aren't talking about typing, please be nice to the bot.
Please and thank you.
Right. This is about architecture. We're going to look at the actual logic that bridges the gap between a fun chatbot toy and a production-grade system that actually respects your business rules.
So if you're a developer listening to this, we are going to get into the code structures and security. And if you are a non-technical founder, we're going to explain why your AI sometimes just ignores your safety rules and how this architecture fixes it.
It is a really fascinating look at the plumbing behind the magic.
Let's just dive right in. First up is the context engineer, which when I first saw this name in the repo, I pictured a guy in a hard hat.
Naturally.
But it's actually a subsystem.
Yeah, think of the context engineer as like a master librarian or a dedicated researcher, because in a typical bad AI setup, you just paste raw text into the chat window.
Right.
It's totally unstructured, it's messy. But the context engineer is a pipeline. It takes that raw mess of files, URLs, notes, and it standardizes it before the AI ever even sees it.
It's doing all the prep work.
Exactly. The context engineer service, that's the core class in the code, is designed to take specific inputs. But here is the first really interesting constraint. It is incredibly picky about what it accepts.
I noticed that.
It takes files, but only text-based files, so .txt, .md for markdown, .text.
No PDFs, no Word docs, which seems honestly really restrictive because the whole business world runs on PDFs.
It is restrictive, but for a very good reason. Actually, 2 reasons. First, have you ever tried to copy-paste from a PDF?
It's a complete nightmare. You get headers right in the middle of sentences.
Page numbers interrupting paragraphs.
Weird line breaks everywhere. Yeah.
Right. And that noise completely confuses the large language model. By forcing text or markdown, you ensure the input is totally clean. But the second reason is security.
Security?
Yeah. Binary files like a .docs Word file are essentially containers. They can hide macros, malicious scripts, payloads.
Oh, I see. So if I build a tool and let users upload a Word doc to my AI, I might inadvertently be letting them upload a virus that executes right on my server.
Precisely. The report explicitly mentions that they block binary files to prevent malicious payloads and to ensure what they call deterministic parsing.
Deterministic parsing, meaning no surprises.
Exactly. They want to know that the text they put into the system is exactly the text the AI reads. Nothing hidden in the background.
That's a great point. It's a safety gate right at the front door. Now, the system also takes URLs, right?
It does. You can pass it a JSON list of websites, but again, it doesn't just blindly trust them. This is where we really see the difference between a weekend hackathon project and real enterprise software. It fetches the content asynchronously, but before it reads a single byte of that web page, it sanitizes the request to prevent SSRF.
Okay, let's unpack that acronym for everyone. SSRF, server-side request forgery. What is the nightmare scenario they're avoiding there?
So imagine you are a hacker. You tell the AI, hey, go summarize this URL for me. But the URL you give it is actually an internal IP address, like localhost/admin.
Oh, or something deep inside the company's cloud network.
Right. So the AI server essentially tries to visit itself or its secure neighbors.
The AI becomes a proxy for the hacker to scan your internal network. That's terrifying.
It is. So the context engineer prevents this by validating that the URL points to the public internet before it fetches anything. It's a very strict trust but verify approach to the web.
Okay, so we've got clean text and safe web content. Now we have the magic trick. The report talks about a function called construct optimized prompt,
Yes.
which sounds a bit like marketing speak, honestly, but it's doing something very specific.
It is. A novice developer would take all that safe text, glue it together, and just say, here is the context.
Huh.
But this system behaves like an architect. It builds a highly structured prompt with clear sections.
Like chapters in a book.
Exactly. It generates a role definition so the AI knows who it is. Then a documentation context section, where it carefully places the uploaded file content. Then a URL context section.
But the most interesting part to me was the security and trust boundaries section.
Yes, it injects OWASP-style constraints.
Right, OWASP, the gold standard for web security.
Right. The system automatically injects instructions like the principle of least privilege. It effectively tells the AI, if you are writing code or suggesting a solution for this user, do not ask for any permissions you don't strictly need.
That's huge, because it's baking safety into the prompt itself. It's like telling a contractor, hey, build me a deck, but you are strictly forbidden from touching the electrical wiring under any circumstances.
That's a perfect analogy, and that leads to the output. Because the goal of this context engineer isn't just to have a nice chat, it's to produce artifacts.
I love that term, artifacts. It sounds so expensive and permanent.
It really just means structured, highly useful outputs. The system has a specific endpoint called extract artifacts. It actively watches what the AI generates.
Okay.
If the AI writes a standard operating procedure, an SOP, the system detects it. If it writes a skill package, it detects that too and extracts it.
Wait, hold on. Skill package, that sounds like a video game power-up. What is a skill package in this context?
It's actually very meta. A skill package, which is often saved as a skill.md file, is essentially a markdown file that serves as a strict set of instructions for another AI agent.
Whoa, so we are using the context engineer to read our messy Slack threads and PDFs, and its output is a perfectly clean training manual for a totally different AI.
Exactly. You go from messy human conversation to a clean instruction manual for an autonomous agent. That is the true power of context engineering. It transforms raw info into executable business logic.
That is incredibly cool. So we've built the car, we have the context engineer creating these structured artifacts, but now we run into the second problem in the deep dive. And this is where the deeper engineering really comes in.
The flat goal problem.
Right, intent engineering. This part really resonated with me because I think every human deals with this when managing people, let alone machines. The report says that if you tell an AI to be safe, clear, and concise, it treats those as three completely equal friends.
It sees them as a flat, comma-separated list. Safe, clear, concise.
But in the real world, and specifically in business, values conflict. They are almost never equal.
Give me a real-world example of that. Okay, imagine you are a bank. You want an AI to explain a wire transfer protocol to a customer. You tell the AI to be concise and safe.
Okay.
Concise pushes the AI to be as short as possible. Safe pushes the AI to list every single possible warning, regulatory check, and edge case.
Those are direct opposites.
They're in constant tension. If the AI views them as equal goals, it might decide to cut a crucial safety warning just to save a paragraph of text because it really wants to be concise.
Because it thinks it's doing a good job balancing them.
Right. It thinks it's helping, but it just created a massive legal liability for the bank.
Because the goal list was flat. It didn't know which priority was the boss.
Exactly. The audit in the report found that goals were literally just a string of text. There was no way to tell the system, hey, safety is non-negotiable and brevity is just a nice to have.
So how does intent engineering actually fix this? It introduces a value hierarchy, right?
Yes. It breaks the goals down into L1 and L2 implementations. Let's start with L1, which is the instruction layer. The system now lets you tag every single goal with a priority label.
And those are non-negotiable, high, medium, and low.
Exactly. It's totally explicit. When the system builds the prompt, using a function called build_num_system_prompt, it creates a specific directives block. It tells the AI, 1, non-negotiable, safety, 2, high H, clarity.
So it's basically giving the AI a built-in tiebreaker rule.
It's a conflict resolution algorithm for the model's own decision-making.
Yeah.
It tells the LLM if you are ever forced to choose between being short and being safe, you absolutely must choose safety.
That makes total sense. But the report says L1 is really just asking the AI nicely. It's still just text in a prompt, hoping the model listens. L2 is where this gets really interesting for the CTOs listening. This is the safety floor.
Right, it's the infrastructure innovation. To understand L2, you have to understand that this architecture uses an intelligent router.
Okay, let's unpack the router.
In modern AI sectors, you usually have a stable of different models. You have a smart, expensive, slow model like a GPT-4 class, and you have a cheap, fast, slow or dumb model. The router's entire job is to save the company money by sending easy tasks to the cheap model.
Because if I just ask what is 2 plus 2, I don't need a supercomputer. Send it to the cheap one.
Exactly. But here is the massive risk. Imagine a user prompt that looks really simple on the surface. Draft an email to the client.
Okay.
The router looks at that, scores it as easy, and automatically sends it to the cheap model.
But what if that email contains highly sensitive legal advice? And my value hierarchy says safety is non-negotiable.
That's the problem. The cheap model might not be smart enough to handle that legal nuance. It might leak data or give terrible advice. That is exactly where the L2 solution steps in. It introduces a router tier floor.
A floor, so you physically cannot go below a certain level of intelligence.
The math here is really specific. The router assigns a complexity score between 0 and 1. If a goal is labeled non-negotiable, the code intervenes and forces the score to 0.72.
Why 0.72 exactly?
In this specific system, 0.72 is the exact threshold that guarantees the request gets routed to the smart LLM-based tier. It completely bypasses the cheap models.
So the non-negotiable tag overrides the complexity check entirely. Even if the prompt looks simple, the system says, no, this is high stakes. Bring in the expert.
Correct. And if it's tagged HEH, it forces a score of 0.45, which guarantees it uses at least a hybrid model.
I love the analogy you used earlier for this. It's like a law firm policy.
Right. Think of it like a strict firm rule book. You might say, look, I don't care how simple a contract looks. If it involves client safety, a senior partner must review it.
You don't let the summer intern handle it just because it's only 1 page long?
Exactly. L2 enforces that senior partner review at the actual code level.
It's essentially spending money to buy certainty.
It is. And the report notes this is strictly additive. The floor can raise the router score, but it can never lower it. It's a safety ratchet. It will never say, oh, this is low priority, force it to the dumb model. It only ever intervenes to upgrade the intelligence.
So we have the context engineer building the artifacts and intent engineering ensuring the AI actually respects our priorities by forcing the right model to do the job. But I have a practical question about how this works day to day. Does the system just remember these values forever?
That brings us to persistence. The system saves these user hierarchies in a Postgres database, and they use row-level security, or RLS.
Which is standard, but absolutely vital. It means user A can't hack the database to see user B's corporate values.
Right. The database enforces the privacy at the row level. But the really clever engineering challenge here, honestly, the detective story part of this report was about caching.
Oh, the cache! This is the case of the stale answer.
Exactly. Let's play it out. You ask the AI, write a deployment guide. The system generates it. And because generating text is expensive and slow, it saves or caches that answer for next time.
Makes total sense. Saves money if I ask again.
But then, 5 minutes later, you realize you forgot something crucial. You go into your settings and update your value hierarchy. You set safety to non-negotiable. Then you go back and ask the exact same prompt again. Write a deployment guide.
And the system sees the prompt as the same.
And it hands you the old, unsafe cached version. The stale answer.
Disaster.
Yeah.
You think you're safe because you updated your settings, but you're actually looking at old, dangerous logic.
Yeah.
So how did they solve the stale cache problem?
They implemented what they call a hierarchy fingerprint.
A fingerprint.
They take your entire value hierarchy, all your goals and your new priorities, and mash them together into an MD5 hash. It creates a totally unique 8-character code. For example, a 1B2C3D4.
And they stick that fingerprint directly on the cache key.
Yes. So the cache key isn't just write a guide anymore. It becomes write a guide plus fingerprint X.
Oh, that's brilliant.
If you change a single priority in your settings, the fingerprint completely changes to something like Z9Y8. The system looks for the old key, can't find it, and is forced to generate a brand new, fresh answer that respects the new safety rules.
That is such a smart, low-level fix. It ensures that my current intent is always respected, even if the actual question hasn't changed at all.
And for the developers listening, there's one more core principle here called zero regression.
I really like this part. It's basically the rule of don't break the old stuff.
Right. If a user doesn't want to use these fancy hierarchies, if they just want a standard, fast chatbot experience, the code behaves byte for byte identically to the old version.
Because the fingerprint is empty.
Exactly. The router floor doesn't trigger. There is absolutely no performance penalty or latency overhead for opting out of the feature.
It's polite engineering. It doesn't bloat the system for people who don't need the heavy enterprise features.
Precisely.
I want to zoom out for a second here. We've talked a lot about structure and rules and MD5 hashes, but how do we know any of this is actually working? Is there a test?
The report details a really robust evaluation framework, .py. And this is important because often in AI, people just vibe check the output. They read it and go, looks good to me.
Vibes is not an engineering metric.
No, it's really not. These developers used metrics inspired by DSPy.
DSPy.
Yeah, it's a framework that treats prompts much more like executable code. They're actively measuring context detection. They run automated tests to see, did the AI actually reference the security file we uploaded? Did it actually pull data from that URL? And they get a hard numerical score.
So they are essentially unit testing the AI's reading comprehension.
Yes. It's measured rigorous engineering. And on the security side, besides all the prompt injection defenses, they are validating everything. We mentioned blocking binary files, but they also strictly validate file extensions and MIME types. It's true defense in depth.
It really feels like we are finally moving away from AI as a magic box to AI as a component.
That is the single biggest takeaway here. You cannot treat the LLM as a wizard that knows everything and does everything right natively. It is just a component in a larger software system. It needs input validation, it needs output boundaries, and it needs a supervisor.
And intent engineering is that supervisor.
It absolutely is.
So let's synthesize this for everyone listening. We have two big concepts today. How do they fit together in practice?
Think of it this way. The context engineer builds the car. It gathers the raw materials, the steel, the glass, the engine, and puts them together into a working vehicle, an artifact like an SOP or a skill package.
Okay. And intent engineering.
Intent engineering is the GPS navigation logic. It decides the route. But more importantly, it decides the rules of the road. If the GPS sees a shortcut that goes through a really dangerous neighborhood, intent engineering is the underlying logic that says, no, safety is non-negotiable. We take the long way around.
And the L2 router floor is the engine governor, ensuring you actually have enough horsepower to make that smart decision.
Exactly. If the decision is highly complex or risky, L2 ensures you're using the Ferrari engine, not the moped engine, to navigate it.
For the founders listening to this deep dive, this really represents the massive shift from AI toys to enterprise AI.
An enterprise tool respects business rules. It guarantees that safety policies aren't just polite suggestions you whisper to a chatbot. And for the developers, this repo is a literal blueprint on how to use things like pydantic models and defensive routing to build something incredibly robust.
It effectively stops the AI lottery where you just cross your fingers and hope the model behaves today. It forces behavioral guarantees.
It does. But, and here's where it gets really philosophically interesting.
I knew there was a but coming.
This entire system relies on a conflict rule. The user explicitly defines what happens when goals collide. You log in and say safety trumps speed.
Right.
But as we move toward truly autonomous agent software that executes these SOPs without us actively watching, who defines the ultimate conflict rule when the user just isn't there?
Ooh, that is a heavy question.
Right now, the human sets the hierarchy in the database. But if an AI agent is running a critical infrastructure task at 3:00 a.m. and hits a brand new edge case situation, is a simple tag of safety first enough information?
Probably not.
Or do we need a much more complex ethical hierarchy hard-coded into the software itself? I mean, if the agent has to choose between deleting user data or letting the whole system crash, and the user didn't specify a rule for that, what does it do?
That is a fascinating and honestly slightly terrifying thought to leave us with. We are successfully building the architecture of intent, but we have to be really, really careful about what intents we are architecturalizing.
Exactly. The code itself is neutral. The intent is entirely human. And if we don't code that intent explicitly, the AI is going to make a guess. and we might really not like the guess it makes.
Well, on that slightly ominous note, we are going to wrap up this deep dive. Whether you're a developer building the pipeline or a founder just trying to get your automated team aligned, remember this. Context creates the capability, but intent defines the outcome.
Very well said.
Thanks for listening, everyone. Go build something safe, structured, and intentional. We will see you next time.